Can you tell me how you would design WhatsApp? Hey everyone, welcome back to another Exponent System Design mock interview. My name's Kevin Wei, and on today's show we have Roshan. Before we get started, Roshan, do you mind telling the audience just a little bit about yourself, and then we'll get into the mock interview?
Of course, Kevin. Thank you. Thank you so much for inviting me to this, interview. My name is Roshan. I work as a SD2 at Amazon, and I spend most of my time building highly scalable systems and creating impact in the lives of billions of people.
Excellent, thank you, Roshan. So let's do this question today. Can you tell me how you would design WhatsApp?
Yeah, of course. So maybe like usually whenever we start the system designs, first we start with collecting all the requirement. So Kevin, what I'm gonna do is first, try to get all the requirement that the WhatsApp application could have, because today, everybody is aware of WhatsApp and it has like a bunch of features. But in the interest of time, maybe we will be developing only some, essential features. Is that fine, Kevin?
Yeah, that sounds good. Maybe you can tell me what these essential features, what the priorities might be.
Sure. So yeah, maybe I'll start writing it down. So first thing, like maybe we can start with very basic. So today WhatsApp is used, to send and receive messages, um, between two peers. So yeah, this is one of the most basic feature where one person can, send and receive message to another person. So this is like the minimum feature that any typical chat application should have. The second one could be, group messaging, where a member would create a group. They will add some X number of people in the group. And whenever the person sends the message, all the other parties in the group will receive it. And everybody will know that who has sent that message. So that's the second feature that we may have. And we can also have, like, once the message has been sent, the other person would be really interested to know whether it has been delivered. Second one would be like, rather there should be three receipts, basically: the sent receipt, the delivered receipt, and the read receipt. So maybe in case if we want, we can add that as well: sent, delivered, and read receipts. So yeah, this could be another feature. So Kevin, anything so far, like on these three features, do you want to add something?
Yeah, this makes sense. Sending and receiving messages, this seems like a P0. Group messaging is interesting, and sending, delivering, read receipts, just to let the user know that the app is working and that everything that they're doing is working as planned. I think we can stick with this for now, and then if we want to add more features, we can if we have time.
Okay, so now maybe I'll just ask some more clarifying questions on this, the first feature. So when we say messages, so are we talking only about the text messages, or the person can send documents, images, videos? Is that feature available in the first version?
Yeah, great question. Let's assume that most of the messages are going to be text or images.
Okay. Okay. Okay, got it. So I think, yeah. So maybe let me add some title in here. WhatsApp system requirements. Okay. So now maybe I'll proceed with the, the design of like what is going through my mind. So let me draw some icons in here. I think
Nice, I love it. Some visuals for us.
yeah. So let's say, like, this is the user A, and we also have another user in here, B. Okay. So now we need some kind of a protocol where A can communicate to B. but in a more secured way, so that we don't get, like some third party should not be able to, decode the message and, read it, because that would be a pretty awful experience for the user B, like to both the users for that matter. So we need some kind of a protocol where we can, establish that communication. And I think we have something called WebSockets. So WebSockets was specially designed for peer-to-peer communication. So maybe I can quickly write that down. 1 second. WebSockets. However, just using WebSockets won't work. How would my system know that, this user B is present in some network? Like B would be connected to some network, right? So we need some kind of a, database where we know to which box is A connected to and which box is B connected to. So let me just change this a bit. Let me put this here and let me remove this line over here. And yeah, so let's say maybe I can put this line here. Okay, so now let me see. Okay, so we need API gateway. API gateway 2. Okay, so basically what would happen is this this phone, this user A is connected to API gateway 1, and there's another user B which is connected to API gateway 2. Now there should, like, maybe we can have a microservice. Let me put that here, and we can call it as a session service. 1 second. Session microservice. Basically, the responsibility of session microservices to connect with a DB, and it will tell us which user is connected to which box or which API gateway. So maybe I think, yeah. So say suppose when the message, when A wants to send a message to B, it would first go to API gateway and then connect to this microservice, and this microservice will fetch the box number of the user B, and then the session microservice will connect back to API gateway number 2, and from there it will go to B. And the protocol that we will be using here is WebSockets. Maybe I can write that down real quick. So this is how I think I would be able to, send and receive messages. And I think this solution is also pretty scalable. How are we going to ensure that is maybe the type of database that we will maintain here is maybe NoSQL database. We can use that for scalability purposes as well. Yeah, NoSQL, like maybe DynamoDB.
So why would you use NoSQL here rather than a relational or SQL database?
As and when the number of users grows, we want the systems to, scale, right? And NoSQLs are one of most of the time why we use NoSQL is because it helps us during scaling, and we don't have to stick to one schema. The schema could be pretty dynamic. So yeah.
Okay. For scalability, that makes sense.
Yeah, and maybe I think I can quickly write that format as well. So for now, I'm just thinking of a key value pair. So it could have something like the key. 1 second. Yeah. So the key could be the user, and the value could be the box or the gateway. So by that way, we'll be able to identify which user is in which box. So yeah, so that would only this problem, this particular design will solve the first requirement, but we still have not addressed the images thing. So usually for static content, we have S3, that is the most preferred feature, like most preferred option. So maybe I think I would stick to that. So maybe I think when when user wants to send a image, right? The only difference between text and image here is, by the way, we are not planning to store this text anywhere, right? Because as soon as this text reaches the session microservice, we are only going to get the user name and their box number, and then send the text message as it is. We don't need to store this text anywhere. However, in case of images, I'm thinking, would it make sense to store it?
We can say that we don't want to store it just because we don't store text, so we also don't want to store images for privacy.
Yeah, privacy purposes. Okay. So yeah, in that case, then I think we are good with first requirement. Maybe before we go to second requirement, let's complete the third one. So send, delivered, and read. Now, as soon as this user A has sent a message, like as soon as a message is received by the session microservice, what we can also do is immediately send a response back, like an acknowledgement to user A that your message has been received by us. This session microservice can do that. So maybe what we can also do is, like, let me put that real quick. Okay, and the text here would be read message sent acknowledgement. Okay, and maybe let me put some numbers as well. So basically, the number 1 here indicates the first part of it, because the message has been sent. Now, once the session microservice has got the box number of the user B, and once it has sent that message to B, what B can do is it can send back an acknowledgement to session microservice. So maybe let me put it this way. API gateway, and from here to session microservice. And let me add some numbers here. So this is more of a message received acknowledgement. And what I can also do here is I can add another text in here. It says message delivered acknowledgement. Okay, so just to summarize, user A has sent a message to API gateway. API gateway would have communicated to session microservice, and as soon as the session microservice has got a message from A, it will send a message sent acknowledgement. That is point number 1. And session microservice would interact with DB. It would get the box number, and it knows exactly where user B is. So it would go to API gateway 2, and API, like, this message will get redirected to B. Now, as soon as the message is received by B, B can again send a acknowledgement. So that is point number 2. And as soon as session microservice gets that acknowledgement, it will send a message delivered acknowledgement to A. So sent has been covered, delivered has been covered. Now read receipt. So the thing is, as soon as the user B opens the message, we can do exactly similar thing what we did for point number 2. So maybe I think I can draw another box in here.
So what happens here when user B reads the message?
Yeah, message read acknowledgement. Yeah. So now once the message has been read, we need to somehow indicate that to user A, right? So what we can do is, again, we can use the typical feature of what WhatsApp is already leveraging, like maybe changing the color of the double ticks. So as soon as session microservice communicates that to A, the double ticks might be changed to double blue ticks. So that would be point number 4, I believe. Or
Got it.
let me put, this is point
Yeah, that
number
makes
4.
sense. Cool. Yeah, that makes sense. So this makes sense for peer-to-peer text and images. The text and images are not stored; they're just transmitted through the network. We have sent, delivered, and read receipts. Can we cover the group messages here?
So now let us talk about the group messaging. So what essentially are we trying to achieve here is step number one, some user will create a group. Step number two, the user will add some X number of people. By the way, I forgot to ask this, Kevin. How many, what is the maximum number of people who can be in the group?
Yeah, for simplicity, let's say 10 people.
Okay. Maybe I think I can write that down real quick. Max 10 members. Yeah.
And feel free to tell me if in the future we want to change this to like 99 or 999, how that would change.
So maybe I think I can write that down. Should be scalable to more than 100 plus members. Okay, got it. So maybe I think I'll start with 10 first, and then let's see how we can make it more scalable, Kevin. So
Makes sense.
So maybe I'm just thinking of how I can tweak the existing design a bit to start supporting the group messaging. So here, if you see, when a message was sent, we had this key value pair with only one user and only one box. So what if we have a list, like a list of a map? So whenever a group will get created, so what would happen is a list will get created with a map having the key as the user and its associated box number. So by that way, what would happen is whenever a message is sent, the microservice or the messaging microservice will iterate over each of the elements in the list, or rather the key value pair. It will check the the user name and its associated box number, and it will exactly follow all the procedures that we have created for one. Does that make sense, Kevin?
Yep, that makes sense. How can we ensure scalability here?
Okay, the problem here is that when we are sending a message, we don't want to send the message in sequential order. We can actually parallelize things here. We can ensure that like say suppose there are 100 members in the list, we can separate them in a batch of 10 or 20, and we can have a main thread who will initiate a message, who will initiate the group messaging, but the child thread will equally distribute the number of items in the list and then send it to them parallelly, Kevin. By that way, the other set of members in the list do not have to wait until the first set of members are done.
Got it. Cool. All right. That takes care of group messaging. I have one more question before we wrap things up. So you have user A here connected to API Gateway 1. You have user B connected to API Gateway 2. If we have user C, where would user C be connected to? Is it to their own API gateway, or would they share a gateway?
No, they can share their gateway. Like it's not mandatory that they need to have their own gateway. They can definitely share the gateways.
Okay, and how are the users assigned to the gateways? Is it randomly, or is there some structure there?
Well, for now, I don't think we need any structure, but yeah, they will be assigned randomly, Kevin.
Okay, got it. Cool. Thanks, Roshan.
I think I understand where you're getting with this. You somehow want to ensure that not all the users end up in getting connected to one gateway. Right. So I think in order to solve that problem, what we can do is we can have a limit on the number of users getting connected to a gateway. So by that way, as soon as that count reaches the max count, we know that, okay, the gateway is fully occupied. Now we have to move to the next gateway.
Yep, that makes sense. Yeah, thanks for clarifying that point for me. All right, cool. Thanks, Roshan, for your time. I have a few pieces of feedback here that I'd love to point out, and then I'd love it to turn it back to you. Maybe you can give some advice to the audience as well.
Yeah.
So you did a really good job prioritizing the features in the beginning, figuring out what should be in the MVP. You know, WhatsApp is a huge app, and you were able to pick the ones that are most important to discuss for the MVP. I think you also did a really good job of distinguishing some of the ambiguous parts of the question. So, right, sending and receiving messages, this could be anything from text to photos to videos to audio messages. And you did a good job pointing out that ambiguity and helping to hone in the scope there around text and images. And the last point I wanted to make is that you did a really good job checking in with me and figuring out what questions I was trying to ask you, not only at the end there, but also in the beginning. After you finished talking about sending and receiving messages, you didn't just move on to the next part of the question. You paused and you asked me if I had any questions before moving on. So I really appreciate your mock interview here. And before we wrap things up, do you have any pieces of advice for the audience if they have their own system design interview?
Yeah, of course. Thank you, Kevin. Thank you for acknowledging this mock interview. And for people who are, watching this video right now, maybe I think I would just summarize of whatever Kevin has said. Just try to ask as many clarifying questions that you have, because the only person to whom you can talk during the interview is your interviewer. So they are the ones who are here to help you out. So maybe you can ask as much clarifying questions. And whenever you are designing something, so whatever is going through your mind or whatever you are drawing, just call it out loud, so that the interviewer knows what is going through your mind. And in case if you make any mistakes, they will immediately stop you, or they might tell you to tweak your solution a bit. So yeah, the key thing here is during the system design interview, it's really important that you keep talking to your interviewer instead of just keeping it with yourself. So yeah.
Makes sense. Thank you, Roshan. Thanks for the audience for watching, and good luck with your upcoming system design mock interview.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video is valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching, and good luck on your upcoming interview.